Hi there, today's lesson is solving radical equations, and I just want to let you know, obviously a radical equation is an equation that has a radical in it, and radicals can appear like this with the actual little house, or of course, as we learned in the last section, a radical equation could have an expression where there's a rational exponent, a fraction of the exponent. So we're going to do 4 examples today. The first 2 I'm going to show you are going to be ones where there's only one variable on one side of the equation, and you will find that those are going to be the easier ones. The ones where there's 2 variables on either side of the equation is going to be a little bit more complicated, but again, I will show you how to do that in the examples as they come. First thing we should know about solving a radical equation is that you want to isolate the radical expression. So the radical expression is basically all of this, the entire portion of it that is underneath the little house. So you want to isolate that. And so to do that, I'm going to subtract 2 from both sides. And that'll leave me with the square root of 3x minus 2 equals 4. And then we will square both sides, like so. And the square root and the square will cancel, leaving us with 3x minus 2 equals 4 squared is 16. And now, this is not very complicated to solve at all. It's just like a regular equation. So we add 2 to both sides. And we get 3x equals 18. And finally, we divide by 3. And we get that the answer here is x equals 6. It is very important in the case of radical equations that you always check your answer, because there is a potential for extraneous solutions, and you need to make sure that the solution actually works. So that's not going to be a big deal when you have the easier ones, but when you get to the more complicated ones, you're going to have to be really careful with that. So for example, in this guy, I can check it very quickly, just verbally here. Again, we're saying that x is 6, so 3 times 6 is 18. 18 minus 2 is 16. The square root of 16 is 4. And 4 plus 2 is 6, so it works. So we know we have the right answer. So now, I'll have you try this one. And here's another one. And this guy has 2 options going on. And I want to do this one very carefully, 2 different ways. And you guys can decide which method you want to use. The first method I'm going to use is to basically take my rational expression and actually write it as a radical. And we learned in the last section how to go back and forth between radical and exponential form. So my first method is going to come over here. I'm going to say 2. Since the 3 is on the bottom, that's the cubed root of x minus 2. And the 2 on top tells me to square what's inside the radicand. Now this method is a little bit longer, but it's also more clear as to what's happening and why we're going to end up with 2 answers in this case, and we didn't end up with 2 answers in the first example. So the first thing we want to do is, like we did before, is to isolate the radical. So we divide both sides by 2, and now I have the cubed root of x minus 2 squared equals 25. Okay, now to get rid of the cubed root here, we are going to raise this to the 3rd power. Now remember that the cubed root is the same thing as 1/3, and the reciprocal of 1/3 is 3. So we're going to raise it to the 3rd power, and then that is going to cancel that guy out, and then you're going to get x minus 2 squared remains, and 25 to the 3rd power is a really big number. I think it's something like 15,000. I did this earlier. 15,625. Real big number. All right. And now we have the square root. And you guys know what happens when you have the square root both sides. Oftentimes students forget this step. But when you square root both sides of an equation, you have to put plus or minus. And it turns out that the square root of my answer there is 125, but it's plus or minus, okay? And I want to come back to this in a second, but remember that anytime you square root something, it means that you're going to have to put plus or minus. A square root, a 4th root, any even root means that you're going to have to put plus or minus. Now that's easy to do when you can see the square root physically take place. You can see that I physically went square root of each side. It's a lot harder to do that when you have the other method, which is why I'm telling you this is going to be more clear of a method, but it's also longer. So you can decide what you want to do. So positive 125 plus 2 is 127, and negative 125 plus 2 is negative 123. And you can see that because of that plus or minus, we actually ended up with two possible solutions. So we're going to check them real quick. If I come back over here and I say negative 123 minus the 2, that gives me negative 125. If I take the negative 125 and raise it to the 2/3 power, I get 25, and 25 times 2 is 50, so it worked. Again, if I do 127 minus 2, I get 125, and raise to the 2/3, and I'm going to get 25 times 2 is 50. So these both solutions are going to work. So I get two solutions this time, and again, that happened because we took the square root, we took the even root of both sides. So how does that pan out when you're doing it the other method? The other method is a little bit easier. It means that I can write the problem down as it is, and in one step I can, well, divide by 2. That part is the same. So I get x minus 2 to the 2/3 power equals 25. So far, they're the same thing. At this point in time, I raise this power to the reciprocal of 2/3. The reciprocal of 2/3 is 3/2, and I do that on both sides. And this is where it's not always clear, but you have to be really careful that first I'm going to explain why I raised it to the 3/2 power, because we know that when you have a power raised to a power, you multiply. And I'm trying to get that to cancel, so I'm trying to get it to be a 1. X minus 2 to the 1 power. Okay? So when I take 2/3 and times it by the reciprocal, I in fact get 6/6, or 1, which is what I want. Now, that explains why I flipped it over when I raised it to that power. Now what's happening is, this is where it gets kind of confusing. You have to make sure that anytime you square root two sides, you put plus or minus. When you do it this way, it's not clear whether or not you took the square root because you don't see a square root. But anytime you have a 2 on the bottom, which is basically the fractional way of saying square root, anytime there's an even number on the bottom, you're required to put plus or minus 25. Sorry, 125. So if I take 25 to the 3/2 power on my calculator, I will in fact get 125. But you have to remember to put plus or minus, because anytime there's an even number on the bottom of the fraction that you raised it to, then you're going to have to put plus or minus. Okay? So I hope that makes sense. If it doesn't, you can I can explain it again in class, next class period. So again, we get the same answers because positive 125 plus 2 is 127. Negative 125 plus 2 is negative 123. So it's important that you put the plus or minus, because if you don't, you'll be missing one of the solutions. Okay? So now you can try this guy, and then I will go on to the other types of examples. So here we have another situation where now we have to be really careful that we check for what they call extraneous solutions. An extraneous solution is a solution that you get by doing all the math correctly, and yet when you plug in the answer, it doesn't work. Like in the previous example, we had two solutions. I plugged them both in. They both worked. We're good. An extraneous solution is when you plug it in and one of them doesn't work. There's nothing that you did wrong in the problem. It's just part of the domain of the original equation that's the issue. So first things first, we still want to isolate the radical. Even though you're tempted, as a lot of people are, you're tempted to bring the x's together. That's not what you want to do. You still want to isolate the radical expression. So I'm going to move the 5 to the other side, and that's going to give me the square root of x minus 3 equals x minus 5. Now, to get rid of the radical, I'm going to square both sides. Okay, so then that cancels that, and I get x minus 3. So now my radical is gone, but now I've got this binomial expression squared on the other side. And students make mistakes here a lot because they try to distribute x squared minus 5 squared. That is not how you do that. You will remember, or recall hopefully, that a minus b squared is equal to a squared minus 2ab plus b squared. So be very careful that when you do this, that you use this formula and that you don't just distribute it because you'll get the wrong answer. So this should be x squared minus 2 times x times 5, which is 10x, plus 5 squared, which is 25, which is now a quadratic. And you can solve this equation, again the radical is now gone, and you can solve this equation in the same way that you would solve quadratics. So I'm going to move the negative x, or I'm going to move the x and the 3 to the other side. So now it's going to be 0 equals x squared minus 11x plus 28. And at that point, you can try to factor it, or you can use quadratic formula, whichever works for you. I'm going to factor it. I happen to see that this is very factorable. So I'm going to say the factors of x are 1 and 1, and the factors of 8 are probably 7 and 4. 7 times 4 is 28. And I need them to both be negative, so that when I add negative 4 and negative 7, I get negative 11, which is what I want in there. So my factored form is x minus 7, x minus 4 equal to 0. So my two solutions are going to be 7 and 4. If I add 7 to the other side, add 4 to the other side, I get two solutions, 7 and 4. But I have to check them to make sure that they actually work. So here we go. I come over here and I say the square root of 7 minus 3. 7 minus 3 is 4. The square root of 4 is 2. And 2 plus 5 is 7. And since x equals 7, then that works. What about the 4? In the case of the 4, I'm going to have, and I'll come over here and do another color. In the case of the 4, you're going to have the square root of 4 minus 3 plus 5 equals 4. Okay? Because it says here that I'm going to replace the x's, both of these x's, with 4. So that's what I've done here. Well, 4 minus 3 is 1, and the square root of 1 is 1. So you get 1 plus 5 equals 4. But that's not true, because 6 does not equal 4. So you can see how everything was done correctly, and yet 4 doesn't work. So you want to make sure that you distinguish between an actual solution and an extraneous solution. So the actual answer here is that x equals 7. You might even want to put 4 as extraneous, EXT. So the answer 4 does not work. All right, so now you can try one. Don't forget to double check both of your answers. And then I'll give you one more example. This is going to be our final example for today. And this guy is with the fractions here. And in this case, again, you might want to go with the radical notation, but that's up to you. What's happening in this case is that you have two radicals. Okay, this is a radical expression, this is a radical expression. So what we can do is to put one on each side. Normally we want to isolate them, right? So you want to put only one on each side. So I'm going to add 3x plus 4 to the 1/4 power to both sides. Okay, so that's going to cancel out that guy, and so I'll end up with 2x plus 1 to the 1/2 power equals 3x plus 4 to the 1/4 power. Okay? Hopefully that makes sense. But now what you'll notice is they don't both have the same fractional exponent here. So I want to raise this to a power. I'm going to do the easy method instead of the rewrite it as a radical, which you can do if you want. But what's going to happen is if I put a 2 here, which is the reciprocal of 1/2, then this fraction will be gone because 1/2 times 2 is 1. But this fraction won't be gone because 1/4 times 2 is 1/2. And I'll still have a fraction. Okay? So in that case, what you want to do is not that. You want to raise it to the 4th power, which is actually the reciprocal of this guy. Because if I do that, then 1/4 times 4 will be 1, and it'll cancel. And over here, it won't cancel, but it won't be a fraction anymore, because 1/2 times 4 is 2. Okay? Also, notice that there's no, I'm not raising it to a fraction where the bottom number is even. This is the top number, because if anything, it would be 4/1, and 1 is odd on the bottom. And remember that earlier I said, whenever you raise it to a power, and the power is even on the bottom, that's when you have to put plus or minus. But in this case, you don't have to, because you're not raising it to a power that has an even number on the bottom. The even number's on top, not on the bottom. So we're okay with that. And so now I'm just going to continue here. This is going to be 1/4 times 4, so they're going to cancel. And you'll get 3x plus 4 on this side. On the left, you have 4 times 1/2, which is 2. And so you'll have 2x plus 1 squared. And now, again, like the previous example, you can kind of see now how it's going to be very similar. I have to use the formula which says, this is my a, this is my b. So I have to do a squared. And when I do a squared, I have to square the 2 and the x. So it's going to be 4x squared plus 2ab. So 2 times 2x times 1. So 2 times 2x is 4x, times 1 is still 4x, and then b squared. That's how I break that part down, equals 3x plus 4, and now I want to move my 3x and my 4 to the other side, and I get a nice little quadratic, so it'll be 4x squared, and then 4x minus 3x is going to be 1x. And 1 minus 4 is -3. Okay? So now equal to 0. So there's my quadratic, and I'm going to factor it. So up here, the factors of 4, I'm going to use 1 and 4. The factors of 3 are 1 and 3. And I need one of those to be negative, so I'm going to do it like that. And that means that if I go like this, nope, that's negative, sorry. If I go like this, 4 times 1 is 4, 1 times -3 is -3, and 4 minus 3 equals 1, which is the middle term there. So my factorization will be x plus 1 and 4x minus 3 equals 0. So my solution here is x equals -1, and if I add the 3 and divide by 4, it's going to be 3/4. So I get x equals -1 and x equals 3/4. And now you want to make sure that you check your solutions. So I'm going to check the -1 and the 3/4 over here. So I'm going to go 2 times -1 plus 1 to the 1/2 power. And then I'm going to do 3 times -1 plus 4 to the 1/4 power. Okay? And when I subtract those two, it's supposed to equal 0. That's the question. Does it equal 0? Well, 2 times -1 is -2. And -2 plus 1 is -1. And -1 to the 1/2 power is the same thing as saying the square root of -1, and that's imaginary. So off the bat, right away, we already know that the -1 won't work because it's imaginary. So this guy is not a solution. This one is extraneous. Now all we can do is hope that the 3/4 works. So I'm going to come back over here. I'm going to use my little eraser. Hopefully this works. Alrighty. And we are going to put 3/4 in there and hope that it works. I'm going to erase this little guy here. All right, and see, we're gonna see if this time it works. Okay, so 2 times 3/4 is actually 1/2. Let me turn on my calculator here. 2 times 3/4 is 3/2, sorry. And then you add 1, and you get 5/2. Okay, so we're gonna get 5/2 to the 1/2 power. And so raise that to the 1/2 power. And you get approximately 1.58, okay? So now we're gonna go here, you're gonna get 9/4, because 3 times 3/4 is 9/4. And then you add 4, and you get 6.25, which is basically 25/4. If you take 25/4 and raise it to the 1/4 power, you get, lo and behold, 1.58, which is nice because we know that if you have 1.58 and subtract 1.58, you get 0. So the 3/4 works. So my only solution for this example is 3/4. The -1 did not work. It was an extraneous solution. So now you can try that little guy. And once you've done that, then you will be done with the lesson for today. Thank you for watching, and I'll see you in class.